All right, I'm going to start from the very beginning where I open up a browser. I happen to be using Google Chrome for this, but you're probably using something else, maybe Microsoft Edge. And all I did just now was I cut and paste the link that I shared in the team site earlier. So if you need a minute to write that down, if you do the same, it's going to bring you right to the same window. Hopefully, you should have already gone through that process of getting set up. I'm going to click on this icon, and when I do, I'm going to choose all the defaults. I'm just going to leave all that and say allow, and it's going to connect. It's already got my password and username. When I say submit, hopefully it's going to bring me right into the system here, and it logs me on. So we're going through a browser window instead of the client, or I should say, I guess the app, the remote desktop app. So you might have to minimize as much as you can. I find that where I am, I can go to like a full screen mode, and that helps give me as much space as I can possibly find on the screen. On your smaller laptops, that's certainly going to be important. So see if you can find something equivalent to that. And with that, we're now ready to use the software. So we're going to start building up our project. Over the course of this class, there's probably going to be numbers of different versions, a lot of different icons that you'll see on the desktop that pertain to the ANSYS software. I think it's probably more convenient to go ahead and lock to your screen. Let's see, here I'm actually having trouble finding. There we go. If I go to the Start menu, I went ahead and pinned the applications that I'm going to want for the most part during this class. So what I found was Electronics Desktop 2022 R2. It's already pinned for me. If you haven't done that, you might scroll down and look in the folders here. You'll see something called ANSYS EM Suite. They're in folders, and as you expand the folder, you can find a number of icons. The one that you want is this right here. So ANSYS Electronics Desktop 2022 R2. And if I right click on this, I can just go ahead and say pin. For me, it says unpin because I already have it pinned. So I'm going to go ahead and launch it just by selecting it right here and give it a second to come up. You should have already gone through the setup here. If not, you will find the rest of the instructions are in the Word document that was shared with you that explain how to set up your user folder. So I'm going to bypass all that for now, assuming that you've already done that. Okay. So this tool is called Electronics Desktop, and we've opened up what's a common environment. I'm resizing some windows right now that are often important for my whole process of building up a project. So hopefully you see a project manager window over here on the left. You'll also see a properties window right below it. And then I've got a message manager window and a progress window. If you don't see these windows, you can probably go to your view tab, and you might find that those windows just simply might not be toggled on. So the check mark here indicates that all of my windows are up, and they're probably docked exactly where you're seeing them, hopefully. So you can always resize them as needed. And I think like this type of real estate looks about good. I've got a nice wide open space here, which I'm going to need, and smaller panels over here around the perimeter on the left-hand side and on the bottom. So this is a common interface, is what we call it. The interface is basically designed to work with a number of different, we call these design types. And over the course of this class, we're going to get familiar with some of these, not all of them, but today we're going to be focused on this thing called Maxwell. And Maxwell is a finite element solver that has particular application spaces. And in this case, it's mostly low frequency or static. What we'll be doing today is a electrostatics simulation. So you'll notice right now I really don't have anything in my product manager in the tree. We call this a tree. The overarching folder is called a project. But as soon as I come up here to the ribbon and insert by clicking a Maxwell design, this gets populated now. Okay, so this is my, I can see my geometry tree is going to be stacked up here, and I can see my 3D view is in the middle here. I have a 3-button mouse. Hopefully you're using a 3-button mouse by now. Trackpad might work, but they just really typically don't work as well. So I highly recommend getting a 3-button mouse. If you have one with a scroll wheel as the middle button, then it typically zooms in and out on the area that you're pointing to. So if I start zooming in on the right hand, right by the cursor, it'll zoom to that spot. And this will get important for later on. You'll also notice that it has a measurement bar that's called the ruler. I can look around the window, around the ribbon here, and I can see a number of things that I might be able to turn on or off. I'm going to go ahead and leave that on for the time being. It's going to be important, or it'll be helpful as a reference as we go through this. So I'm going to introduce you to something called the workflow. That's a term that we use whenever we build up a simulation project, and it really defines exactly what it implies. There's a flow from start to end that we use to build up, the work, the effort that we're actually doing today. So today we're going to build up an electrostatic simulation, something very simple. So what I'm going to do is start by expanding this tree, and you're going to see as we go through this process, I'm going to not touch on every one of these nodes, but I'm going to start to, probably grab a few of them and configure them as we go all the way through building up, a model, putting some geometry in here, defining something called excitations, running the analysis, and looking at results in fields. So a lot of times workflows typically go from top to bottom or from left to right. In this case, we're going to be going kind of this top to bottom flow. You'll notice there's a number of tabs here. We're defaulted to the Draw tab. And every time, if I just start clicking on these different tabs, you'll see the buttons will change. So this is what we call the ribbon. And as I choose individual tabs, the ribbons will change accordingly. So in the Draw ribbon, which is the right place for us to start, you've got a number of different things over here that pertain to creating geometry and manipulating the scene so we can actually view what it is that we constructed and maybe hide objects that we're not interested in seeing and turning on objects. In this example, we are going to build a simple point charge. And when I say point charge, we're going to generalize that to actually a sphere. So I'm going to use this insert sphere icon here. So make sure you're on the Draw tab. And when I go and click on the sphere, you'll see it's giving me some instructions over here. I'm not clicking on anything yet. I'm just, bringing your attention to it. It's also telling me on the bottom left-hand side, this is the instruction that it's giving me. So it's asking me to enter the center position of this sphere. I'm getting some tips here on how to move around and toggle around between different views here. But you'll notice that this grid has been set up in the XY plane, and I can snap to grid points with the way that I have it set right now. So with your defaults, you should see these snap settings are already defined here. So as I move around the 3D space here and don't click, it's just going to snap to different parts on the grid. So it's asking me in the bottom left to enter the center position. I'm just going to literally click on that center position, and the next instruction comes up. You'll see there on the left-hand side, down here it says enter the radius. I haven't clicked yet. I'm just going to basically move around until I'm going to make it just 1 millimeter in this case. So you'll notice here that as I choose a location, it'll tell me on the left-hand side where my position 2 is in the XY coordinates. So if you look over here, position 1 is my reference. So that's where the center of my sphere is at 0, 0, 0. Position 2 is wherever the last location was of my cursor. So watch position 2 as I move it in the x-axis and I get to 1 millimeter. And as soon as I get there, I know that that's exactly what I was looking for my radius. I'm just going to hit the left mouse click button, and that's my sphere. So I'm out of creation mode at this point. I just have a simple sphere, and I should be good to go here. you'll notice that this sphere actually has mapped into a material property. And in this case, the material by default has been given a vacuum. So what that means is that there's actually no material properties of this object. It's the same as if we were in free space. And that's okay with what we're about to do. Something that's extremely important that I probably should have done at the very beginning was to go up to this tab that says Maxwell 3D and go to the solution type option. And when I do that, I can see there's basically these two different types of physics that we can solve for. And the default is magnetostatics. We're going to talk about that at another time. We want to do electrostatics right now. So make sure that you toggle it into electrostatics. Everything else is going to be fine. We'll okay that. I think it's also a good idea to save as you go. I'm not going to worry about where this is saved at the moment. I'm just going to hit the save button. I've already configured the folders. Well, so it pops up as my OneDrive, and that's fine. I'm just going to go ahead and I'll go ahead and keep it. Actually, instead of using that default name, I'll go ahead and give it a name. I'll call it intro. I'll call it intro static charge. And I'll give it a number. This will be the very first intro for static charge. Okay, so it's right there on my OneDrive, so I'll be able to get back to it. So that's actually perfect. We want you to save this to your OneDrive and not the local server machine. With that, what I can do now is I can select the object just by clicking on it. When it highlights pink, I know that I have it selected. It even tells me down here in the bottom left that one object is selected. And I right-clicked to bring up this menu because I want to give it an excitation assignment. So if I go to assign excitation, I'm going to assign it charge. And when I choose that option, it's asking me how much charge do I want to give to this object. So this is supposed to be a point charge. We're going to keep the numbers easy right now. Let's just go ahead and make it 1 coulomb. That's actually a pretty large number, but we're going to go ahead and use 1. We'll go ahead and leave the name as charge. You'll see where that shows up in a second. I'm going to hit OK. And notice in my project tree, this excitations now can be expanded out. It has a plus sign. And when I do that, I can see this charge 1. So now, if I ever want to go back and, if I have a much larger model one day and I get maybe I lose information about what it was that I actually did, I can always go back to this excitations and find all the charges that were assigned. And as I select it, it'll tell me the name, it'll give me the value and what type it is, and it actually highlights. It tries to color the object and let me know exactly what has that 1 coulomb charge. Sometimes that can be handy. The next thing I want to do is I want to make the environment. The environment is basically the surrounding universe. So we have to tell it where the universe ends in this case. And what I'm going to do is make a box around the charge, and that'll be what's called the air box. And I'm going to assign a boundary to that. So I'm in the appropriate draw tab here. I used a sphere earlier for the charge. I'm going to set up this draw a box feature. So once I click that, it kind of goes in this interactive mode like we saw before. It's asking me to enter the box position, and it's keeping track of all the locations right here. So this would be the origin, I guess, or I should say the start point of this box. Now, this isn't where I'm going to want it in the end, but I'm going to show you how to move this around. So let's just go ahead and use this grid. As I zoom out, I want this box to be I want it to be pretty large. I'm going to use a box that's going to be, let's say, 25 centimeters, or maybe we'll do half a meter. And if that's too big, we can always ratchet it down. So what I'm going to do is just drop a location. So I dropped the first location, and now if you look at the bottom left again, I'm not clicking anything yet. It says enter the position. It says enter the opposite corner of the base rectangle. So it's keeping track of my locations right here. And as it does that, I'm just going to click any position. I'm not going to worry about where it is at the moment. And as I move it up with my middle mouse, if your view starts to kind of get really confusing to you, you can always hit this green check mark, or I should say fit all, and then it's gonna really render my view properly. So the last thing it wants right now before I click is going to be enter the height. And when I do that, I can see I've got this bounding box that's not quite even close to centered on my sphere, and it doesn't equal the numbers that I was asking you to give it. So to fix that, I can go to create box, and when I do that, my properties panel shows me the position of the box and the size. So we talked in class about XYZ coordinate systems. Well, I can see where my global coordinate is. It's right at the center of the charge, and I want this box, if I choose create box again, I want it to be a half a meter box that's centered on that position. So to do that, I'm going to choose the starting location of the box. You'll notice that these are numbers separated by commas. You have to get the syntax right. So I'm just gonna highlight over that, and I'm gonna choose negative 250 millimeters, comma, negative 250, comma, negative 250. And then I'm going to move the cursor into the X size, and I'm going to choose 500. 500 for the Y, whoops, not 1,000, and then 500 for the Z. So if your numbers look like this, as soon as you click out of that space, you can zoom out and see a very large box has been centered on it. Now I can't see that charged sphere anymore. So one thing I can do is I can choose this box. If I select it, I can make it transparent. Right now the transparency is 0, but if I click that, it'll open up this slider and I can set the transparency to anything I want. And I'm going to make it 80 or 81. And I can, sure enough, I can zoom in and I can see my charges at the center there. I can also change the color. Maybe I'll indicate that this is air by choosing, I don't know, blue as the sky or something along those lines. Now we're about to select boundaries for this surrounding air box. So keep in mind, what we're trying to do is we want to calculate the charge distribution from this 1 Coulomb point charge in the center of this air box. But what we have to tell the software is basically how big the universe is in this case. So this bounding box is representing the universe. And that's it. It won't solve for anything outside of this box. But the way that this model goes is that basically it's setting up a system where the fields are supposed to go to 0 at the edge, at infinity, and we don't have infinity in this case. We just made our boundary just basically half a meter. So I have to choose these faces and set them so that they're equal to, let's say, 0 at infinity. And that's what I'm going to do. So I have to change the selection mode right now. So in the past, what I did was I just chose the object. And it tells me at the bottom that one object is selected. What I want to do now is select faces of this object. So if I go into the dead space of this 3D viewer here and I right click, I can go into selection mode and choose face. And we have to remember to get out of this mode later on or it can be confusing. But since I'm in this face mode, it's going to choose as I hold control and select all the individual faces. All of them, once they all turn pink, I know that I have the complete bounding faces. And it's telling me there's 6 faces selected. That's exactly what I would expect for the cube. And as long as they're all still selected, now I can right click and I can choose assign boundary. And in this case, I'm sorry, I meant to say excitation. So I'm going to choose assign excitation. Instead of charge, this time I'm going to choose voltage. And what I'm going to leave is just the default here. So I'm going to say 0 volts. So Without getting to a discussion about what voltage is, we're just going to say that, look, this is basically, simulating as if this is out, as if the edge of this box is infinity, as far as the universe is concerned. It's a little bit of a stretch. So we'll say okay. And with that, you can see I've got these two excitations. So we've created the geometry. That geometry, we've got two different geometries here. We have the sphere that you can hardly see right now at the center of that box. We have the bounding box, which is really the surrounding environment. So those are the two geometry components that we created. We march down this tree. We created these excitations. We have a charge right there at the center. I can zoom in and verify that it's been assigned properly. Okay, we gave it 1 coulomb. It's telling us right here. And we also have a voltage that's been set up on the bounding faces of this box. So the next thing that we want to do is set up an analysis. Well, it's actually called the setup. So if I go to this analysis node and I right click it, I'm going to choose add solution setup. So we're going to play around with these values. We'll see if I'm actually not going to use the defaults right now. I'll try to explain this as we go through it. I'm going to change the maximum number of passes to, let's just say 20. I don't know exactly what's going to happen. I'm going to change the percent error to, instead of 1%, I'm going to change it to 0.1%. And I believe everything else is going to be okay here. I'm not going to set anything else. So make sure that you have those same numbers, 20 and 0.1 for your error. I'm going to OK it. And with that, we should have a valid model. To find out, I'm gonna go and verify. So if I go, so right now this whole time we've been in the Draw tab, and I'm going to switch over to Simulation tab. And the first thing I want you to do is just hit this big check mark. So make sure you're on the Simulation tab, and I'm going to say Validate first. And hopefully you get all of these check marks that come back. If not, if any of them are red, I recommend that you go and look through the messages that are going to show up here, and maybe go back, rewind this video, and find out possibly where you went wrong. Hopefully you'll be able to figure that out. So I'm going to close this. Before I say Analyze All, I'm going to hit this HPC Options button, and I'm not going to click anything except just this Edit right here. I only have this one thing that's selected, and when I say Edit, you guys have to remember that we're sharing a server. The server has a number of cores. Those are basically the compute cores that are on this machine. And so I think 4 cores is probably a decent number. If you guys are doing this problem together, you'll be competing against each other for that space. But I think that's a good number. If your number is lower or higher, go ahead and change it to 4. And we'll see what happens. So I didn't change anything, so instead of hitting OK, I'm just going to hit cancel. But if you changed it, make sure you hit OK. With that, I'm going to go ahead and hit the Analyze All button, and you're going to see in the message manager or the progress window that some things are going to take place. And right now it's going through what's called this adaptive pass process. And it should be going through it pretty quickly. And this is something that we'll talk about in a later segment. But usually you would expect a number of adaptive passes to take place before it finally settles on one that basically, tells the software that the solution that it has is as accurate as it needs to be based on the information that we gave it. So we're going to let that continue on. One thing I like to do is typically while that's taking place, I can go into this Results tab, and I can actually look at this solution data. So I went from simulation to results, and if I toggle on solution data, I can see this number in the convergence tab. It should ultimately be getting lower. It's going from some very high number, and the trend is for it to get smaller and smaller until it gets to that 0.1 that we were looking for. And again, that's part of the finite element method. We'll talk about that, but the computer is running a simulation over and over again until it sees the number that we asked for. And we really don't know if it's going to get there right now. I put numbers in there that were hopefully going to get there. So when I switch to plot mode, I can go from pass to I can go to delta energy, and I can see this is a plot that we typically like to follow. We want to see this go from the very high number in the beginning to our number of 0.1. So it's going to keep solving over and over again. If it doesn't get there in 18 or 19 passes, it'll max out at 20, and we'll probably add a couple more passes and try to get there again. And what I find is that we actually got lucky. We got to our convergence right in time. We had actually one more pass that it could have gone through. So in 19 passes, it achieved a number that was better than the 0.1 that we defined, and it ended up with a 0.07. We'll talk about these things in the table here. There's tetrahedra. We'll talk about what that is. At some point we'll talk about the total energy and the percent error that is really involved in this solution. We didn't look at any other things right now to set up, to evaluate force and torque and those sorts of things. We'll probably get to that when we get to the magnetostatics. For now, this tells us that we should have a valid solution. So let's talk about what that means next. So what does this solution mean? We're going to see if we can visualize some of the stuff that we've talked about in class. The main thing really is the fields. That's a very important characteristic of a charge. So what I want to do now is actually plot the fields. So if I go to my coordinate system, or if I look underneath my coordinate system, I'll see there's these defaults have been already set up. There's a number of planes. So if you know what a coordinate system is, you're looking at the only one that we have in the model. It's a Cartesian coordinate system as I flip around. You'll also notice that these planes are defined in reference to that coordinate system. So when I choose global XY, it's showing me a small portion of the plane of the global XY. This really goes out to infinity in all directions. And as I zoom out, that image of the purple is gonna scale with what I'm doing, but it's really not a real thing. It's just like an imaginary, two-dimensional plane that is flat to the XY coordinates there, or I should say axes. So when I choose global XZ, then as you would expect, that's basically a cross section and a slice right there in the XZ plane, and of course you would expect the same with the YZ. So these are like constructs that are all referenced to that coordinate system that are really convenient for us to visualize things like the electric field. So let's stick with the XY plane for now, and as long as I have it selected, which I can tell I do because it's highlighted in purple right now, I can go to the field overlay, and when I go to field overlay, all I have to do is select it. And now I'm going to right click it, and I'm going to choose fields, and I want to see the electric field. And these are functions, basically. These are variable names for functions. And what I want to look at is the magnitude of the electric field first. So as I choose mag E, I know that that's the component that it's basically trying to sift out. So we talked a little bit about magnitude of vectors. Well, this is going to be a mathematical operation on the vector field. I'm going to leave all these defaults. So if I, just to make sure that you followed all that, I canceled out of it so I can do it again. If I right click the field, if I right click field overlays, I go to fields, electric field, E, and I choose mag E. And I'm not going to do anything else here. I'm just going to leave all the defaults as you see. Don't worry about any of this right now. I'm just going to say done. And when we do that, it's going to give me a plot. This is not a very interesting plot at the moment because of the scale. And another thing that we want to talk about in class is things like scientific notation and where the origin is, 0 versus these very large numbers here. And this is a very inconvenient view for us right now. And I can change this into something that is a little bit more appealing, because the issue is that we have very small numbers on the outside that are practically 0 because we define them to be 0, that go to very, very large numbers at the very center. And whenever you try to plot really, really tiny numbers like 0 next to things that go up to 10 to the 15, it's very hard to view them on what's called a linear plot. So it actually makes sense that everything looks like it's 0. As I zoom in, I can actually see that that's not the case. I can see that as I look at the perimeter of that charge, those fields get very, very high. Now, this is supposed to be a representation of a point charge. It's actually not a point. You would actually call this a dielectric sphere in a sense, because even though it's vacuum, this is actually a sphere and not a point. But the further you get from it in distance, as I zoom out, the more it looks like a point, and it's a pretty good approximation of one. I want to change that scale. I'm going to do it by double clicking in this legend here, and it brings up this window where I can we'll play around a lot with this later in another segment, but right now all I wanted you to do was go to scale, and let's change it from a linear scale to a log scale, and that's all we have to do. And it looks a lot more interesting there. And if you remember, with some of the number with the number scale exercise that we did on the first day of class, I had you plot some numbers that were very different in size. It's not exactly what we're looking at here, but you can see this is going to a log scale. It really divides up the space a lot more. So our low level number is no longer 0. It's actually a fairly high number, but it's not nearly as high as that 10 to the 15. So if you count them out, 8, 9, 10, 11, 12, 13, 14, 15, that's 7 orders of magnitude between those numbers as opposed to 15. And it makes it a lot easier to actually see the differences in this space here. So I want to end on one more plot. We did a magnitude plot. So as you can guess, this doesn't tell us anything at all about direction. So I'm going to right click. Actually, before I do that, let me get you used to this. I'm going to expand this out, and underneath this node of electric field, I've got this node that says Mag E. If I right click it, I can just turn off visibility, and now I can't see it. If I left click it, it'll highlight on until I click off. If I right click it, I can turn plot visibility on, and now it stays on. Okay, so just so you know how to get it back on and off, I'm going to go ahead and keep it off for the time being. I'm going to untoggle plot visibility. But now what I'm going to do is I'm going to choose the same XY plane, and I'm going to right click in field overlays. And now we're going to do electric field again, but this time we're going to do a vector plot. So as I choose vector, you may have guessed I'm not going to have you do anything different right now. I'm just going to have you accept the defaults and say done. And when we do that, we can actually see the vectors. As time goes on, we'll go and manipulate this so we can see the views of the vectors a little bit different, and we'll certainly spend a lot of time doing that. But if you've made it this far, that means that you have a successful electrostatics simulation of your very simple point charge model, and this is really the beginning of lots of different variations that we'll be doing on this throughout class. I wanted to bring your attention to a couple things here. Is that the behavior looks a little strange. It's not, it's certainly symmetric, but you'll notice that the flaring out effect that you'll see on the edge of the box here on the faces, that's an artifact of how we truncated our solution. So in reality, if you were to have a charge in free space, you would not see this normalizing, I guess, of the, I should say, pointing into the faces of those zero fields. Since I should say zero voltage faces. That's an artifact of the way that we set up that problem. It's very common to do things like this where we set up a boundary space that's bigger than we want. Most of the work that we're going to be doing is going to be taking place in the region closer to the charge, which means the fields behave the way that we would expect, and they don't take on any of the artifacts of the outer boundary. So it's a pretty common thing in these engineering simulation scenarios. So we'll talk about that more as we go along. The last thing I want you to do is I'm going to go ahead and save this. So that went to my OneDrive. But the last request that I'm going to ask you to do is go to File, and now I want you to archive. So when you archive, I want you to keep the results. Go ahead and keep these two toggles on. I'm gonna, if you choose to type notes in there, you certainly can. When I say OK, this time I'm just gonna keep it on my OneDrive. I'm gonna add my initials to it. I hope that you do the same. So I'll put JPB, you can put your student number, whatever you want to do to make sure that it's identified and I can track this to you, because when I save it, the last thing I want you to do now is upload. Once it says it's done, it's packaged up and ready to go. If I was to go and find my OneDrive, I can go to my folder, bring up my, actually this is the one that I want. And you'll see there's a number of drives that are available on the server here. Those probably get wiped out every few days or so. So it's very important to go find your own OneDrive. And here's mine. And I can see my intro to static charges in here. I also see the archive file that I put my initials onto. This is the one that I need you to upload. So somewhere on Schoology or Teams, wherever I ask you to find the video for this assignment, I'm also going to ask you to upload that somewhere. So this is the file that I need you to point to, and it's important that you end the session by showing me and delivering that model. I hope this was good and you're able to make it through the steps, and we'll certainly be talking about this in class next time.